Okay, so today we're going to take a look at what are called constraints. I'm going to start out with the sketch. Remember, tell it where to sketch. And the constraints are this set of commands up at the top. See, that one's coincident, concentric, parallel, tangent, horizontal, vertical, perpendicular. Let's take a look at these. We're going to start with, what is it? Coincident. All right, so let's make a rectangle. And I'm going to use my line tool. I don't have to do it this way. But I make a triangle. And let's say that this point of my triangle, or any point, and that point of my rectangle, or any other point of the rectangle, we want those to be in exactly the same place. I'm going to go to my coincident constraint and select one point, and then the one that I want it to be in exactly the same spot, I'll touch the other one. And now those two points always will be together unless I get rid of that coincident constraint. What could happen, by the way, is that I could do something like this. I could say, all right, I want this point and that point also to be coincident. Might give me an error. Say, like, look, that can't be done. So let's, I'm going to go back and leave that the way it was. So by making the one point coincident, we've constrained this so that that must be that way, which may preclude us or keep us from doing something else and changing something else if it forces the drawing not to keep this coincident. So let's see, what's our next thing? Concentric. I'll make a circle, and I'll make another circle, and I'll make another circle. And let's go to our concentric tool, and now I'm going to say that this circle and that circle, we want them to be concentric. What's that going to do? Puts the one inside the other. I could even say, you know what? I want this to be part of our concentric circles. Now we have even more concentric circles. So concentric circles are perfectly centered within one another. Real quickly, I don't have to do it that way. It can be useful, but notice that when I put my cursor over the center, even I get close. When I get to the center, it lights up. It knows that I'm looking for the center. So that's also a concentric circle. You can do it by using a center point circle and just starting the center point circle from the center of the previous circle. So okay, what do we do? Coincident means the same point. Concentric, two circles that are inside each other. Parallel. I mean, it's easy enough to do this without using the parallel. There, we can kind of see that those are parallel. But what if they weren't? What if it, maybe it was really a really small line and you couldn't tell. I could say parallel. I say that line and that line, I want to be parallel. And it straightens them out for me. Okay, fine. What if I took my tangent? Tangent means that a line must just barely touch the surface of a circle. So let's see what happens if I try to make this line that I wanted to be parallel and make it tangent. with this circle. Well, that's not what we wanted to do. So let's say tangent, line, circle. Okay, well that's, it's coming up here to make this, so the reason it's doing it that way, let's try this the other way around. Let's try tangent, circle, line. Same thing. Okay, so it is tangent if we extend this line out. Let's undo that, and let's try this line. And let's say tangent, line, circle. Okay, so it shows that it's making it just barely touch our line. Great. Horizontal, you can make a line perfectly horizontal on the screen, and vertical is the opposite. And let's try perpendicular. I'm going to take this line and that line, and it wouldn't let it do it. Probably because something else was constrained. Let's try making perpendicular, this and that. All right, let's try to make sure. I'll make sure now that I have a line that doesn't have some other constraint that's stopping us. So I'm going to make this line, and let's see if this works for me. Perpendicular, this line, that one. Went away. Do not know where that went. Let's try one more thing. Here. And here. And we'll try perpendicular one more time. This line and that line perpendicular. Notice, it didn't necessarily put them touching each other, which is I think what must have happened here. I just don't see where the line went. It just made it perpendicular to it. We don't know where it is, but these are at 90 degrees to each other. And we'll do this last one, normal, which is sort of like perpendicular. And I'm going to take this, and I'm going to say normal, this line to this circle. Let's see what happens. So it kept the line at its location and made it come out of the circle at a 90-degree angle. So, okay. So, you know, in practice, these are going to have more use for you than just sort of playing around like I did. But coincident, 2 points are tied together so that they can never be apart. Concentric, circles that are perfectly centered inside one another. Parallel, you know that. Tangent, a line that touches a circle but just barely. And perpendicular, remember that it will be 90 degrees to the line, but it may not put it right up against that line. It will just make sure that the angle of that line is perpendicular to the other angle. And finally, normal is sort of the opposite of tangent. Instead of just barely touching, hitting a line that hits a circle and forms a 90-degree angle with the tangent line. So if that line was tangent to that, then this would be 90-degree angles. Okay, bell's ringing. Got to finish this up. Good luck with that.